Welcome back to the new playlist of Data Engineering Mastery. This is a new playlist where the oldest one was about mathematics of thinking, where we discussed about algorithms and maths. Within this new playlist, we'll be talking about real production pipelines, real problems, real fixes, real failures. And by the way, I am launching a Python formation. If you wanna subscribe, you can fill in the form within the description. And without further ado, let's get started. This episode answers one of the most debated questions in data engineering: Delta Lake, Parquet, or Iceberg. Which one should you use? I have seen teams spend months migrating from the wrong formats. I have seen lakehouse architecture collapse because someone picked Parquet or a silver layer that needs merge operations. I have seen vendor lock invite teams that went all in on Delta before their platform went multi-cloud. So today, a technical deep dive into all the three, what they actually are under the hood, a feature comparison matrix, performance benchmarks, Python code for the same operation in all three, and the decision framework you can apply right now. So most of format decisions are made in the first week of a project. They are usually made quickly by one person without a framework, and by the time the wrong choice is obvious, it's too late to change cheaply. Three stories I have heard from engineering teams. We just used Parquet 6 months in. They needed to update individually rows in their customer table. They realized they had no mechanism to do this without rewriting entire partitions. What should have been a 5-line merge become a multi-hour ETL job that ran nightly. Their SLA broke. We went full Delta, everything works great on Databricks. Then the company brought in a new partner that ran Apache Flink. Delta Lake's Flink support was limited at the time. Migration to a neutral format took a quarter. Iceberg solves everything. They adopted Iceberg, but nobody set up catalog management correctly. Two teams were writing two tables registered in different catalogs. Debugging metadata conflicts took weeks. The format choice shapes your entire lakehouse architecture. Get it right before you build on top of it. So the first thing most people get wrong is thinking all the three are the same category, while they are not. Apache Parquet is a file format. It was created in 2013 by Apache Foundation. It's a columnar binary format for storing structured data. That's all it is. A way to efficiently store data on disk. Parquet does not have transactions. It does not have update semantics. It does not know anything about your table structure. It's just a file format. Delta Lake and Apache Iceberg are table formats. They are built on top of Parquet. They add a metadata layer that gives you ACID, guarantees versioning, schema enforcement, and upserts. Delta Lake was created as Databricks in 2019 and open source to the Linux Foundation. It adds a transaction log directory called Delta Log, a sequence of JSON files that records every operation ever performed on the table. Apache Iceberg was created at Netflix in 2018 and donated to the Apache Foundation. It was built specifically to solve the limitations Netflix experienced with Hive-style partitioning at the petabyte scale. It stores metadata in a catalog layer, making it completely engine agnostic. Look at the three cards, the strengths and limitations. So the Parquet universal grid compression, columnar, no ACID delta. We have full ACID, native Spark time travel, Databricks centric. For Iceberg, engine agnostic, hidden partitioning, full evolution, and catalog complexity. So let me show you exactly what is on disk for each format. because the physical structure explains the capabilities. So for Parquet, look at the left column, you see partition folder, year 2024, month 1, and Parquet files inside them. That is the entire structure. No transaction log, no metadata outside the file headers. If you want to update a row, you must read the entire partition, modify it in memory, and write back the full partition. That is not an update, it's a full rewrite. For Delta Lake, look at the middle column. The key addition is the Delta log directory. So this contains a numbered JSON files, 00.json, 001.json, etc. Each JSON file records exactly what happened, creates, writes, merge, and which Parquet files were added or removed or updated. Time travel works by reading older JSON entries. An update generates a new Parquet file and a new JSON log entry. The old Parquet file is marked as removed in the log. It's not deleted immediately. For Iceberg, look at the right column. The metadata lives in the catalog layer. The metadata JSON file describes the table schema, partition spec, and snapshot history. Each snapshot points to a manifest files which lists the actual Parquet data files. The catalog knows which metadata version is current. This is why Iceberg is engine agnostic. Any engine that speaks the catalog protocol can read and write the table without reading a Spark session. So let me walk through the feature matrix that matters for production decisions. The ACID transactions for Parquet known, for Delta and Iceberg full. ECID, if you need to run concurrent readers and writers safely, Parquet is not an option. For row level updates and deletes, Parquet must rewrite the partition. Delta and Iceberg native merge update delete commands. This is the deal breaker for slowly changing dimension, GDPR deletion requests, and late arriving data corrections. For the time travel Parquet, there is no history. For Delta, it's unlimited versions via version as off or timestamp as off. Iceberg, unlimited snapshots via snapshot ID or timestamp. For schema evolution, Parquet manual and risky, no enforcement in write time. Delta, add column, drop column, rename column, enforced by the transaction log. For the Iceberg, it's full schema evolution without any rewrite of the existing data. Multi-engine support, this is the critical differentiator. Parquet is universal, every engine reads it. Delta is Spark first, improving on other engines, but still Databricks centric. Iceberg runs natively on Flink, Spark, Trino, and Hive, the true multi-engine standard. For partition evolution, Parquet fixed at table creation, Delta replace partition support, and for Iceberg hidden partition. The partition spec is the metadata not exposed at the physical column. You can change partition strategy without rewriting data and without breaking existing queries. So compaction, Parquet, you have to write your own ETL job. Delta, the optimize command handles compaction. Iceberg, the rewrite data files action handles it. Let me show you now the benchmark results that matter in practice. 100 gigabyte dataset partitioned by date on a representative Spark cluster. So read performance analytical scan, select some revenue where dates between two dates. Parquet 1 second, 1.2 seconds, the fastest because there is zero metadata overhead. Delta Lake 1.4 seconds, minimal overhead from the transaction log check. Iceberg is 1.3 seconds, snapshot scan adds about like 100 milliseconds. So the difference is negligible for reads. If read performance is your only concern, Parquet is fine. Upsearch performance, so for the upsearch, when you need upsearch, Parquet is simply not in the conversation. And for small file problems after streaming, after 24 hours of micro batch streaming writes, measures query degradation, Parquet, it takes over 8.4 seconds, 10,000 small files, no compaction mechanism. Delta Lake takes over 1.6 seconds, optimize and Z order. Run it in the background. Iceberg is 1.9 seconds. Rewrite data files, handles compaction cleanly. So time travel query Parquet NA, you would need a separate backup copy. Delta 1.8 seconds. Native version as of. Iceberg is 2.1 seconds. Snapshot based restore. So yeah, now let me show you like a small Python code that differs the same operation and idempotent absurd. So for the Parquet, the left panel, there is no native merge. You have to implement it yourself. Read the existing partition, merging pattern with pandas. They overwrite the partition. Note the warning comment in the code. This is not atomic. If the write falls after the read, you have a corrupted partition. This is exactly the kind of production bug that silently destroys your data. Delta Lake middle panel, 3 lines for the merge operation. Delta table for path gives you the table. Then the Fluent API merge when matched updates all. When not matched, answers all. Execute fully atomic safe to retry, returns operation matrix. Iceberg is the right panel. Pure Spark SQL merge into syntax. The table is registered into catalog. No file path needed. The same SQL statement runs on Flink, Trino, or any other engine without changing a single character. So the progression is clear. Parquet forces you to implement ECAD yourself and you will get it wrong. Delta gives you ECAD but with a Spark flavored API. For Iceberg gives you ECID in standard SQL that any engine can execute. So the decision framework. So 4 questions, answer them honestly. They tell you exactly which format to use. So the question 1, do you need to update or delete rows? Question number 2, are you locked into the Databricks or Spark ecosystem? Question number 3, do you need time travel or audit history? Question 4, is your data platform on AWS with open standards or any other platform? So let me put it all together in the architecture context where you will actually use it. So the medallion architecture has 3 layers: bronze, silver, gold, as we discussed. Okay. So bronze, as we already discussed, the row ingestion. So format Parquet, why? Because bronze is append only. You learn exactly what the source sent. No transformation, no corrections, no ECID needed, just storage. Parquet wins here. The rules for bronze append only, never modify raw data. So that's it. For the silver, the cleanest and conformed layer format is the Delta Lake or the Iceberg. Silver is where you deduplicate, apply lace arraying data corrections, and conform schemas across sources. All of these require merge operations. This is where the table formats earn their cost. So for the gold, the business aggregation layer format is Delta Lake or Iceberg as well. Prefer Iceberg. Why? Because gold tables are queried by Tableau or Power BI, DBT, and potentially Trino. So they need to serve multiple engines without vendor lock-in. Iceberg is better choice here for cross-engine serving. So 4 takeaways. 1. Parquet is a file format, not a table format. It wins for append only, read heavy analytical where you need never update rows, so it loses the moment you need ECID or time travel. 2. Delta Lake owns the Databricks and Spark ecosystem, native merge, optimized Z order, and deep photon engine integration. Choose it for if your platform is Azure Databricks. 3. Apache Iceberg is the open standard for multi-engine environments. Flink plus Spark plus Trino plus Hive all read the same table, hidden, partition, and catalog level metadata. Make it the future-proof choice. 4. Medallion architecture format mapping. Bronze equals Parquet, row, append only, maximum compatibility. Silver equals Delta or Iceberg, merge the duplication, late arrivals, and gold equals Iceberg or Delta. BI survey, multi-engine queries, etc. So drop a like if this helped you make the format decision your team has been avoiding, and tell me in the comments what format is your team using, and have you hit any of the problems we described in the first of the video. Next episode we'll be talking about PySpark for data engineers beyond the basics, partitioning strategies, broadcast joins, handling data skew, and the caching pattern that most Spark tutorials never mention.